So first of all, tell me, uh, can you tell me about the throttling process, where you have seen the throttling process in case of refrigeration?
Sir, in
Hmm.
expansion processor, after refrigerant leaving from the condenser, it goes to the evaporator. In between that, we will observe that throttling process. The throttling
Wait, just
process is
hmm.
it is
Please
highly
continue.
irreversible. It,
Hmm.
it, uh, it changes from the high pressure liquid to the high, high pressure liquid to the low pressure liquid and vapor, sir, to the capillary tube.
Okay. Okay. Okay, can you tell me one thing? Uh, if you have observed the TS diagram of VCRS,
Yes,
okay,
sir.
in that case, the main purpose of the throttling process is to reduce the pressure and temperature. So if both the pressure and temperature is reducing, how does the enthalpy can remain constant?
Sir,
Hmm.
I don't know about this.
Can you show me the TS diagram of VCRS?
Yes, sir.
Yeah, just draw the diagram. Just wait a minute. Okay. Okay. Now tell me, what is the throttling process in this case?
3 to 4, sir.
3 to 4. So can you tell me now that if the pressure and temperature is decreasing, how does the enthalpy remain constant by looking this 3 to 4 process?
Sir,
Hmm.
we are cooling the refrigerant, sir. That's why
Hmm. No, that's not the answer.
we are not we are not changing any. Uh,
Just look at the 3 to 4 process. That is
yes, sir.
throttling process.
Yes, sir.
What is the state of the refrigerant at the inlet? That is point number
It
3.
is saturated liquid, sir.
And what about at point number 4?
It is vapor plus liquid, sir.
So can I say that the specific volume of the refrigerant at the exit will be more as compared to the at the inlet? What do you think?
Yes, sir.
Yeah.
Yes, sir. Yes,
Okay.
sir.
So
Exactly.
yeah. So can you say that now if the temperature is decreasing, that means the internal energy is decreasing, but the corresponding rise in volume will lead to increase in flow work. That means the enthalpy remain constant. Okay.
Yes.
Okay. Just tell me which type of compressor we normally use in case of VCRS.
VCRS, it is
Hmm.
based on the refrigerant which we are using, sir, and
No, no, type of compressor. I just want to know the type of compressor which we
centrifugal
are
and
using.
reciprocal.
Reciprocating.
Yes, sir.
Okay. What do you understand by semi-hermetically, no, sorry, sealed compressor and simply open type compressor?
The sealed compressor, motor and compressor are sealed in a closed
Hmm.
vessel, sir,
Hmm.
and it is open type is it is not sealed in motor and compressor, sir. It is arranged by the shaft or by using weld. We will see that in the hermetically sealed. We will not see any of the explosions.
Okay. Okay. How do you classify the different types of compressor on the basis of principles?
On the basis of principle, it is
Hmm.
uh, positive displacement, sir, is on dynamic compressor.
What is the difference between these two terms, positive and dynamic?
Dynamic type is the energy is transferred in the form of kinetic energy to potential energy, sir.
Hmm.
In the dynamic type, and reciprocal type is energy transferred in the place of displacement type. We will displace the piston and the refrigerant will be compressed.
Okay. Okay. What will happen if I use the axial flow compressor instead of reciprocating compressor in case of VCRS?
Pardon, sir?
What will happen if I use axial flow compressor instead of reciprocating compressor in VCRS? Can we
In
use that?
vapor.
Can we use axial flow
Yes, sir.
compressor in that case?
Yes, yes, sir. We can use, but
Hmm.
based on the reference, we have to adapt to a different system, sir.
Okay. Okay. In the actual domestic refrigerator, how do we achieve the superheating and subcooling?
Superheating based on the heat exchanger in placed between the placed between the evaporator and compressor.
Can you show me the
But
balance and energy balance equation for that heat exchanger which we use in VCRS?
yes, sir, I can show this.
Yeah, just
Wait
write
a
the
minute.
equation for me. Uh, it's not clearly visible to me. M dot H3 minus H4 equal to H1 minus H2 minus H1. Okay. Okay. Just tell me, what will happen if I do the superheating in the evaporators? How does it impact the COP of VCRS?
Superheating, only superheating process.
You are doing superheating in the evaporator. In that case, how does it going to impact the COP?
Yes, sir. Can I draw the TS diagram, sir?
Yeah, yeah, yeah. Yes, yes. You can draw.
Okay,
Just take
sir.
your time.
Sir, work of the compressor will be increases, sir, and refrigeration effect also increases. But COP may increase or decreases. It will be depends upon based on the refrigerant which we are using in the system.
Okay. How can you say the work input into the compressor increases?
Sir, after compression,
Hmm.
when we observe in the pH diagram, sir,
Hmm.
after
pH
compression,
diagram or TS diagram? Okay, yes. Just show me the pH diagram.
pH, this pH diagram, sir.
Okay. Okay. TS diagram. No, you are talking about TS
Yes,
diagram.
sir.
How can you say that the
Now,
1 2 is less as compared to 1 dash 2 dash by looking at this diagram?
sir, this will observe only in pH diagram.
pH
Enthalpy
diagram.
will be after superheating. Enthalpy will be increases as compared to the increases in the evaporator, sir.
Just show
After
me the
com
pH diagram. You just have shown me the TS diagram. Just now, right now,
Yes,
just show me the pH diagram.
okay, sir. Yes, sir.
Okay. Okay. Just in this diagram, how can you say that the enthalpy is basically the work input is increasing, because it is almost equal for me, no?
No,
How
sir,
can
it
you
is
how can you say that?
different. It is different, sir. H2 minus H2 dash is more than the H1 minus H1 dash, sir.
Okay, is this the correct explanation to this? What do you think?
Sir, I think,
Hmm. Okay, just tell me one more thing. Why do we prefer the isenthalpic expansion in VCRS as well as isentropic expansion in the gas refrigeration cycle?
sir,
Why do we
isentropic.
why do we prefer isentropic expansion in gas turbine gas refrigeration cycle and isenthalpic expansion in VCRS?
Sir, in we in vapor absorption system, we are using the sorry air refrigeration system, sir. We are using the turbine, sir,
In
which
what?
give-
In air
we are
refrigeration
using
cycle? Hmm.
we are using the expander, sir. That is called as turbine.
Expander.
Yes, sir.
Okay.
That is turbine.
Hmm.
Specific volume of when we consider the work of the turbine,
Hmm.
specific volume into change in VDP, sir.
Hmm.
So specific volume will be so higher for the gases, sir. So air is considered as a gas. The work will be we will get the work from this expansion of the
Hmm.
air refrigeration, sir. Compared to the throttling process, we will not get from work, sir, because of the specific volume of the liquid will be very low, sir. We will not get significant work from that throttling process.
Okay. Okay, bro.
Mm.
Let me provide my feedback. First of all, see here, you are going for rights, and this entire interview is basically uh, based on the experience basis, no? So most of the
Yes, sir.
question will be framed from your past experience, and or very less question will be asked from this subject, theoretical subject.
Okay,
But
sir.
as as you have answered all the questions, you need a little bit revision. Okay, although you have a knowledge, but you require little bit revision. Okay,
Yes, sir.
because in the last question when I have told you that why do we consider the isentropic expansion in case of gas refrigeration cycle, and why do we using isenthalpic in the VCRS. And first of all, you have to know that the in the gas refrigeration cycle, air is used as a refrigerant,
Yes,
okay,
sir.
working fluid, and air is considered as an idle gas. And if we perform the isenthalpic expansion in that case, enthalpy is a function of temperature. So if
Yes, sir.
just think, if we are performing the isenthalpic expansion in that case, the enthalpy will remain constant. Okay, so if the enthalpy is entirely a function of temperature only, in that case the temperature will remain also same. But the main purpose of using the expansion process is to decrease the pressure as well as temperature. That's why we have
Yes,
to move toward the secondary process, that is isentropic expansion in the gas refrigeration cycle. Okay, although in the VCRS we are dealing with the refrigerant which is two phase, which is in two phase, that is it is in liquid as well as in vapor phase. Okay, so
yes,
whenever
sir.
we perform the throttling process, the liquid enters into the expansion valve and it comes out as a wet mixture. Okay, that you have to understand. Okay,
Okay.
and the answer which I'm expecting from you, that why the compressor work increases. Basically the work input to the compressor is depending upon entirely on the inlet temperature. So if you just think about, if we are performing the superheating process, okay, then the
Yes, sir.
temperature at the inlet of the compressor increases. So with the increase in temperature at the inlet of the compressor, the corresponding work input to the compressor also increases.
Yes,
That
sir.
means the COP will going to be decrease. Okay, but the the answer which you have given, that the COP will maybe increase or decrease for superheating, that's correct, because in the case of ammonia the COP decreases, while in the case of R12 the corresponding COP increases. Okay,
Yes, sir.
but just remember that with the increase in superheat with the increase in the with the superheating process, the temperature at the inlet of the compressor increases, due to which the work input also increases.
Yes,
Okay,
sir.
that you have to know. Is it clear?
Okay. Okay.
Do you have any doubt right now?
No, sir. Regarding the my experience is based on only recreation, sir.
Hmm.
How many subjects do I have to cover in this interview?
First of all, you have to cover the entire thermodynamics. Then you have to cover the refrigeration part and psychometry part. I haven't asked you anything about this psychometry and
Technology.
refrigeration. That's very important. Okay. And after that, you have to know the basic principles of the compressors, air and gas compressors. Okay, all the types. Or one more thing, the hydraulic machines. I can say
Okay, sir.
the centrifugal pumps, reciprocating pumps. It is very important. Okay.
Okay. Thank you, sir.
Okay, okay, everyone. Okay, tomorrow I will take your thermodynamics. Oh, sorry,
Yes,
thermodynamics,
sir.
or I will also take the psycho. I will also cover the psychometric part. Okay, don't worry.
Okay, sir. Okay, sir.
Tomorrow at 1:30 p.m.
Okay, sir.
Okay, at 1:30 p.m. tomorrow.
Okay, sir.
Okay.